Hello everyone, welcome back. In this video, we'll be discussing about the second and the fourth problem of today's weekly contest. Minimum time to revert word to initial state 2 and 1. So both the problems are exactly similar, only difference is in the constraint. As always, we'll start from scratch, that is, we'll try to derive the brute force solution, and from there we'll optimize it step by step. And if you stick till the end, I'm very sure you will be able to understand this problem and also take away a few things which you can apply in future problems as well. So let's get started. The problem states that you are given a zero indexed string word and an integer k. At every second, you must perform the following operations. Remove the first k character from the word and add any k characters to the end of the word, right? So note that you are allowed to add any k characters. It may not be the characters that you have initially removed, right? But you have to do both the operation at every second. Now you have to return the minimum time greater than 0, which will be required to make word come back to the same state as we have started with. So let's take an example. Let's say the word is ABA, C, ABA, and k is 3. So we have to apply some operation that is greater than 0 times, such that after applying those operations, the string gets back to this exact same state. So let's say we apply the first operation. So what is the operation? Operation would be remove the first k characters. So k is 3 here, so remove the first 3 characters and append any 3 character, right? So let's say we removed ABA and we append BAC, right? So if we do that, the string would become CABA and then BAC. So this will be the new string. Now in this, we have to apply the operation again because this is not equal to the original string, right? So we will apply the operation. We will remove CAB and append ABA. So if you append ABA, the string would become ABAC followed by ABA. This will be the string, and this is exactly equals to the original string we have started with. So with just 2 operations, you are able to revert the string to its original state, and you can try out any other possible combinations. You will not be able to get the original string in less than 2 operations, and hence the answer here is 2. So hope the problem statement is clear. Now how to solve this? So forget about minimum operation. Let's just try to focus on, I need to apply some operation and get back the original string. I don't care about the minimum operation right now. Okay, so for this, one of the approach could be, okay, let me remove something from the beginning and append the same thing to the end. Okay, so what we are trying to do here is we will simply keep the characters which are originally there in the string as it is, so that after some rotations, so basically we are doing some rotations, right? We are rotating the string by k. So after some rotation, the string should get back to its original state for sure, right? So let's try to first figure out how many operations will be required or how many rotations will be required such that the string will get back to its original state, right? So in this case, number of rotations required would be LCM by k. So you can figure it out. So one example could be ABA is the first removal, right? And you will append it to the end. So if you append it to the end, ABA would come here and then CABA would be in the forward, right? So this will be the new string after one rotation. Now you apply the rotation again because this is obviously not equal to the original string. So CAB is the one you will remove and you will append it to the end, and this AABA would come in the forward, right? So after 2 rotation, this is the string. In the same fashion, if you apply the rotation again, you will get ACAB in the front followed by AAB, right? So if you keep on doing this, after exactly 7 rotations, you will get back the original string, right? So 1, 2, 3, 4, 5, 6, 7. So after exactly 7 rotation, you will get back the original string. So in other words, what we are saying is, we know that in 7 rotation it is possible to get back the original string. So we have an upper bound here right now. We want minimum number of operations or minimum number of rotations, right? So can we do better than this? The answer is yes. Why? Because here you see, you don't utilize the power that you have fully. You simply take ABA and appended the same at the end, but you have the power to change ABA to any characters you want. You can change this A to Z, maybe you can change this B to ABC or something. So you have this power, but we are not utilizing this power in this series of operations. So if you utilize the power, the number of operations can be reduced drastically. How? So think about it. Let's say you are touching every characters. Let's say you have the power to touch every character and make it anything you want. So if you have this power, it means you can make the character equal to the original one for each of the indexes, right? So if you have the power to, let's say, touch this one, this one, this one, this one, this and this, and make it anything, then you can simply make these characters equals to the original ones and you will get the original string back. So in other words, what we are trying to find is, in how many operations will we get this power to touch every character? And the answer for that is n by k operations, the ceiling of n by k operation. In this many number of operation, if we apply this many number of operations, we know that we will be touching each character at least once. And because we are touching every character, and we already know that after touching we can make it any character of our choice, this will be a valid answer. So let's just take one small example and just go over it. So this was the original string ABA CABA, right? So you take this one, the first 3 characters, and appended something to it. So the one in red is not finalized. It means that we can append 3 characters at the end of our choice, no restriction. So this may not be ABA, this can be anything, right? So now your current string is CABA followed by some 3 characters which you can fill as per your wish, right? Now after CABA, you touch this 3 characters, right? So you change these 3 characters and appended something. Again, what you append is of your choice. So these 3 characters can be anything. Now these 3 characters can also be anything. So now the new string that you have is A followed by 6 characters of your choice. There is no restriction in the 6 characters, right? Now you apply one more operation. You said, okay, I will take these 3, right, and append it to the end. So what you are saying here is, okay, I will take this one and append 3 characters of my choice. So now what you have is a string where every character is of your choice. So once you get here, can't you just make sure that whatever character you put will be equals to the original string? This character is of your choice, right? You can put in this place, you can put A, in this place you can put B, in this place you can put A, and so on and so forth. So finally this final string would be equals to the original string itself, because you have the power to put anything here. So you can put the ones which originally occurred in the original string, right? So hope this makes sense. What we are trying to do here is, we are trying to touch every character and make it independent of what it was before. Once we have this state, we can simply say, okay, whatever character is there, I will put the one which is the starting one. So because I can strategize the entire thing, I know that this one should be A. So when I am putting these characters here, I don't care about these two things. I can put, let's say, X here, and this one I will put A, right? Now CAB should be BAC. So instead of CAB, I will put BAC, right? Now finally AAB should be ABA. So instead of putting AAB, I will put ABA. So hope you get the idea. Basically, if you can touch every character, you can make the original string for sure. Now how many operations you will be able to touch every character? The answer is n by k ceiling, right? So now we know that in n by k ceiling, we are able to get the original string back. Previously, remember, with this set of operations, you were getting large number of operations. Basically, after the LCM divided by k will be your answer, but now we have n by k, which is definitely less than the previous one. So this is now our upper bound. So we are saying that in this many operations, we will be able to get the original string for sure. Now, can we reduce this further? So the answer here is yes, and let's look at it. So we know with this set of strategy, we are able to get n by k ceiling number of operation. This is something we know how to make this, convert the given string into the original string in these many operations, right? We exactly know that. So if we have to get less than this operation, what does that internally mean? This means that you are not touching some character. So in these many operations, you are touching every character, right? And if you want to have less than this operation, it means you are saying that it is fine if I don't touch some characters, right? So what does this mean? So let's say you touch, first of all, you will be touching some characters from the prefix. It can never happen that you are touching these 4 characters and then this character. It can never happen, because to touch any character, you have to touch everything that is there in the previous indexes before, right? Because you are removing a prefix, complete prefix from the string as a part of an operation. So this is not possible. So basically we are touching something and we are not touching something is translating into the fact that we are touching a prefix and we are not touching a suffix, right? So if we have to not touch something, that should be the suffix, right? So if we are touching all these things, just assume that we are touching all these things, it means all these characters will be at the back, and if we are not touching all of these characters will be in the front. The final string would contain the suffix which you haven't touched, so the untouched suffix, right? And then there is a, and then there are characters which you have touched, so this can be anything, right? So this string now should be equal to the original string as per the definition, because we are saying that in less than this operation we are able to get back the original string. So if we are not touching some suffix, then also this string should be equals to the original string we had, right? So what does this mean? This means that what you haven't touched should be equal to some prefix of the original string as well. If it is not the prefix, you don't have any choice. You have to touch something from this untouched as well and move it back to the end of the string. In other words, you will require more operations than you are doing currently, right? So once you have seen this, now think about what you can't touch at all. What are the number of characters which if you don't touch, then also it is fine. These are those characters which are, for which everything afterward should be equals to the original string itself, right? So if we have to get less than n by ceiling of n by k operation, we have to figure out what is the suffix that is equals to prefix, so that we are fine if we don't touch them, right? So let's take an example and do this. So let's say in this case you have to do at least one operation, because it is given the problem that you have to do one operation, otherwise the string is itself the original string, there is no point in the question itself. So you do one operation. In one operation you touch these three characters, right? Now what you are left, so these three characters is in this criterion, this category now, and this CABA is in the front, right? So is CABA equal to the prefix? If they are, then you don't need to touch anything now, you are done, right? But in this case they are not. CABA is not equals to ABAC, hence you have to make another touch or another operation. So in one operation again you will remove this, right? Now if you remove this and move it back, that is, it will be again in this category. So what is remaining or what is not touched is A. So A is there, and then afterwards everything is touched, that means it's your choice what you are putting there. So once you have A here, is A equal to the original string, that is it fine not touching A at all? The answer is now is yes. You may not want to touch A at all and still you would be fine, because this is matching, right? So here you can stop. So in just two operations you are now able to convert the string into the original string. Notice n by k for this particular scenario is 3, n is 7 and k is 3. So if you do n 7 by 3 ceiling, you will be getting 3. So n by k was 3, but in just two operations you are able to get back the original string, right? So that's basically the entire algorithm. Now what will be the time complexity of this entire algorithm if you apply it in the very brute manner? What we are doing, we are simply figuring out whether after one operation whether everything is good or not. So what for after one operation, what you will check whether this suffix is equals to the prefix or not. So how much time we will take in doing this? Basically in worst case or in very brute force manner, you can simply iterate over the entire remaining string which is of length n minus k and check whether they are equal or not. So you will take order n minus k time for first check, right? Now if it doesn't work out, you have to do one more operation, right? So after you do one more operation, how much time we will require in this operation? So again order n minus 2k, right? In the same fashion you will keep on going this until you have exhausted the entire string. So if you just take this k as a constant, in other words you are doing n into n by k number of operations, right? So these many operations you are doing for actually finding out or to actually exhaust the entire string and say, okay, I don't find anything that I can't touch or that I leave untouched, and hence the number of operations will be ceil of n by k. So this is the brute force solution, and complexity is order n square by k, which will not pass the fourth one but rather will simply pass the second question, because the value of n and k is very small here. For the last question, the value of n and k is bit huge, so this solution will not work. Now how to optimize? I would strongly encourage you to pause. I am very sure that you will be able to optimize it from now onwards if you are following the channel for some time. So what we are checking? We are simply checking whether a suffix is equals to some prefix or not, right? So how you can do that? Because you don't want to iterate over the entire string. If you do iterate over the entire string, you will require order n operation for sure. So if you want to remove this n, first of all, you can't remove this n because you have to check how many operations are actually needed among these n by k operations. So that is hard to remove. So we will try to remove this n, that is we want to somehow investigate, okay, is the some suffix is equals to some prefix or not. So that you can do by hashing. You can do it by KMP algorithm as well, but hashing is the straightforward way here. We have discussed this exact technique in multiple videos in this channel. I will link one of these videos, which is again one of the Leetcode weekly contest video only. You can start from this hashing part and look at what hashing actually is if you don't know about that. So once you do this, this order n will be replaced with some order one time with actually some pre-processing that is also order n. So overall the complexity would be order n itself, which is sufficient to pass the given time constraint. So if you have watched this point, I would strongly encourage you to pause and try to code this entire thing by yourself, because as always, without coding this by yourself, you will not be able to retain this for a longer time, and also not able to understand what you actually don't understand right now watching this video. So next we're looking at the code. The code is exactly what we have discussed. We will simply hash the entire string. So we are simply figuring out what is the hash of the entire string with this fill hash function, which basically will populate this powers of p and this prefix hash as well, which we will use to figure out the hash of a substring. It is very similar to how you find the sum or any prefix sum kind of approach, where you want to find something for a substring, you find it for the everything up to r and everything up to l, and you subtract that. So that's why we are finding out prefix hash as well. Now what we actually want to do, we simply want to iterate over the string and check whether after doing some operation whether everything is good or not. So either you can do this, or you can also, instead of this, you can simply say I will start from the kth index first, and at every iteration I will increment my index by k more, right? So that is also another valid approach. This condition is actually taking care of that. So this actually makes actually says that instead of iterating over every index, you are iterating over a jump of k, right? So once you have done this, you can simply figure out the hash of the front and hash of the back. If they are equal, you know that you don't require more operations, you can stop there, right? So hope this entire solution makes sense. If you have any doubts in any of the fees, feel free to follow up in the comment section below. I would be happy to answer. If you want to know about the KMP path, this is also exactly the same. We are doing exact same thing. It's just that the way or the approach in which we are trying to find out whether the suffix is equals to prefix or not has changed a bit with KMP. So nothing else. You can just refer to this code, and I'm very sure you will be able to understand it, given you know KMP algorithm already. So with that, I will end the video here. If you have any doubts, feel free to follow up. If you like the video, give it a thumbs up and do subscribe if you haven't already. I will see you in the next one. Thank you.